My presentation for my lab number 5 about a motion of a rotating falling object. The purpose of this lab is to exemplify how the addition and rotational kinetic energy affects a system and the distribution of energies. So this is the energy principle, where the change in kinetic energy plus the change in potential energy is equal to work and the rotational kinetic energy. So the energy principle describes how when there are no surroundings, the initial energy is the same as the final energy. And rotational kinetic energy. This describes how energy is transformed when a multiple particle system is rotating about an axis. So this is the experiment. The objects selected to analyze were a ball and a roll of toilet paper. The toilet paper was let to fall while rolling. The centers of masses was tracked with tracker for each frame. The data of position versus time were recorded by the app. The origin was set to the starting position of the fall. The movement down is in the negative y direction. This is the experiment. So the system and the surroundings. The system is the ball and earth, and in the other system is the toilet paper roll and earth, and there are known surroundings. The ball only had the force of gravity down, and the toilet paper had the force of gravity down and tension of the paper up. So description of the computational model. The total distance traveled by the objects was 2.40 meters. The properties of the rolling toilet paper were found with formulas. The ball was just acted upon gravity. Here's how I got the acceleration of the toilet paper and other properties. This is the video of the code that I used to create the computational model and the results, where this is the energy graph and the other is the time versus position graph. Comparison. The similarities are that pairs follow roughly the same trajectory, and pairs have roughly the same shape. The differences are that the experimental positions look a little above than the predicted positions, and the experimental curves are not very smooth. Also, the experimental positions ended earlier than the predicted positions. Possible sources of error. I may have miscalculated the distance traveled by using 2.4 meters instead of 2.04 meters. Also, the positions of the experiment may have not been recorded in sufficiently small amounts. In the recording, we can also see that the ball bounced back and hit the toilet paper when it was about to hit the ground. So that changes the velocity when the toilet paper was hit. What does it mean? A system that is let go while rotating and a tension pulling it up from the side will fall with a lesser velocity than an object that just falls with no rotation. In a rotating system, the potential energy has to be converted into both kinetic energy and rotational kinetic energy, whereas in a non-rotating system, the potential energy only has to be converted into translational kinetic energy. What if instead of falling straight down, a rotating object and a non-rotating object were falling down a frictionless ramp? The rotating object would still go down slower, because again the potential energy has to be converted into translational and rotational kinetic energy instead of translational only. Here's the link to my simulation. Thank you.